Number 12 wants us to compute the following definite integral. So we want to calculate the integral from 0 to 8 of 3x squared minus 4x. And this looks a little funky, so I'm going to rewrite it as plus 1/6 x to the 1/3 dx. So all of these terms, we can use undo the power rule in order to anti-differentiate them. So we'll have 3x cubed divided by 3 minus 4x squared divided by 2 plus 1/6, and I would like to leave a little gap when I'm doing fractional exponents. 1 plus 1/3 is 4/3, and when you divide by 4/3, that's the same thing as multiplying by the reciprocal of 3/4. So we want to evaluate this from 0 to 8. Since we actually have to plug in numbers here, I'm going to see if there's anything we can do to clean this up. So these 3's cancel, this 2 cancels, and we get a 2. This 3 cancels this 6 and gives us a 2. So x cubed minus 2x squared, oh, sorry, that should say 2, plus 1/8 x to the 4/3 evaluated from 0 to 8. The fundamental theorem of calculus says you plug in the top bound and then subtract from the bottom bound. So when we plug 8 in, we get 8 cubed minus 2 times 64 plus 1/8 times 8 to the 4/3. And every single one of these terms contains an x, so when you plug in 0, you're just going to get 0. Now, just in case you're a person without a calculator on the test, if you have a calculator, you can simply type this in and see that this works out to be 386. If you don't have a calculator, remember this is 8 squared, so one thing you could do is you could say, well, I'm going to factor out an 8 squared out of these first two terms. That leaves me with 8 minus 2. Here you have 8 to the 4/3. Well, the cube root of 8 is 2. So 2 to the 4th is 16 over 8. So now we have 64 times 6 plus 2. And you probably have to do a little bit of arithmetic there to see that this is also going to be 386.